Welcome to Trendsetters. Join us as we explore the future of megatrends. In the vast expanse of space, a new frontier beckons a cosmic gold rush that promises untold riches and technological marvels. As humanity sets its sights on the stars, the race to mine asteroids is heating up, blending science fiction with reality in a saga of ambition, innovation, and interstellar competition. The cosmic treasure trove. Why asteroids? Asteroids, those seemingly inert space rocks, are veritable vaults of precious metals and minerals. Scientists estimate that certain asteroids contain vast quantities of platinum, gold, and rare earth elements, materials essential for modern technology and industry. For instance, asteroid 16 Psyche, located in the asteroid belt between Mars and Jupiter, is believed to be composed largely of metallic iron and nickel, with an estimated value of $10,000 quadrillion. Beyond metals, asteroids also harbor water, which can be split into hydrogen and oxygen to create rocket fuel, potentially revolutionizing space travel by establishing refueling stations in space. The abundance of these resources makes asteroids attractive targets for mining, offering a solution to Earth's depleting reserves and a stepping stone for deeper space exploration. The pioneers. Who's leading the charge? Astroforge. Founded in 2022, this California-based startup aims to become the first commercial entity to mine asteroids. In April 2023, Astroforge launched a test mission to demonstrate their refining technology in space. Despite technical challenges, the company has secured $40 million in funding and plans a mission to land on a near-Earth asteroid in 2025. Astroforge's approach involves developing small, cost-effective spacecraft capable of extracting and refining materials directly in space, reducing the need to transport raw materials back to Earth. Their focus on platinum group metals aligns with the increasing demand for these elements in various industries, including electronics and clean energy technologies. AARC Space. This aerospace company has pivoted towards asteroid mining with its AMI Exploration Initiative. ARCA Space plans to utilize its Eco-Rocket Heavy launch vehicle and AMI cargo spacecraft to mine valuable materials from asteroids, with missions slated for the late 2020s. The Eco-Rocket Heavy is designed to be an ecological, reusable, and cost-effective rocket, capable of launching 24 tons to low Earth orbit. The AMI cargo spacecraft is intended to perform reconnaissance missions to identify potential mining targets and conduct actual asteroid mining operations. ARCA Space's strategy includes developing a deep space communication network to maintain data links with their spacecraft during missions. The technology. How do you mine an asteroid? Mining in space presents unique challenges, requiring specialized technologies to extract resources effectively. Robotic miners are being developed as autonomous machines capable of operating in low-gravity environments and withstanding the harsh conditions of space, such as extreme temperatures and radiation. These robots can function without direct human intervention, making them ideal for remote missions. In addition, in-situ resource utilization techniques are being designed to leverage materials found on asteroids, such as extracting water for drinking or splitting it into hydrogen and oxygen to create rocket fuel, enabling long-duration missions. Advanced propulsion systems like ion thrusters further support these endeavors by providing efficient, fuel-saving alternatives to traditional rockets. For example, NASA's Psyche mission uses ion propulsion to travel to the metal-rich asteroid 16 Psyche, demonstrating the potential for cost-effective, long-distance deep space missions. The economics. Is it worth the cost? The potential rewards are astronomical, but so are the costs. Launching missions, developing technology, and transporting materials back to Earth require significant investment. However, the scarcity of certain metals on Earth and their critical role in technology make asteroid mining a potentially lucrative venture. Analysts suggest that the first trillionaire could emerge from the space mining industry. The high concentration of valuable materials in asteroids means that a single successful mining mission could yield returns far exceeding the initial investment. Moreover, as technology advances and economies of scale are achieved, the cost of space missions is expected to decrease, making asteroid mining more economically viable. The legal landscape. Who owns space resources? The legal framework for space mining is still evolving. The Outer Space Treaty of 1967 prohibits sovereign claims over celestial bodies, but is ambiguous about resource extraction. In 2015, the U.S. passed the Commercial Space Launch Competitiveness Act, granting American companies rights to resources they extract from space. Other countries, like Luxembourg and the United Arab Emirates, have enacted similar laws, aiming to position themselves as hubs for space mining enterprises. These legal developments are crucial for providing companies with the certainty needed to invest in asteroid mining ventures. However, the lack of a comprehensive international framework raises concerns about potential conflicts and the sustainable management of space resources. The environmental considerations, space junk, or sustainable mining. While asteroid mining could alleviate the environmental impact of terrestrial mining, it raises concerns about space debris and the potential alteration of celestial bodies. Ensuring sustainable practices and preventing the creation of hazardous space debris are critical considerations for the industry. The European Space Agency's Hera mission, launched in October 2024, aims to study the impact of human activities on asteroids, providing valuable data for future mining endeavors. Implementing best practices, such as designing spacecraft to avoid leaving debris and developing technologies to capture and remove existing space junk, will be essential to maintain the long-term sustainability of space activities. The competition. A new space race. The quest for asteroid resources has indeed ignited a modern space race, where private companies and nations are competing to gain a strategic foothold in this emerging industry. The United States is leading the charge with companies like Astroforge, Planetary Resources, and Deep Space Industries, pushing the boundaries of what is technologically possible. Meanwhile, China has announced ambitious plans to mine asteroids as part of its long-term space exploration strategy. The country's Chang'e lunar missions are laying the groundwork for more advanced asteroid exploration missions. Russia, with its well-established space program, is also exploring asteroid mining, focusing on using its expertise in heavy-lift rockets and long-term space exploration capabilities. The European Union, led by countries like Luxembourg and partnerships with the European Space Agency, is positioning itself as a hub for space mining investments by providing legal and financial incentives to companies. This global competition is driving rapid advancements in propulsion systems, robotics, and in-situ resource utilization, creating ripple effects in other industries. While the rivalry could spur technological innovation, it also raises the stakes for geopolitical tensions, with the potential for conflicts over access to and ownership of these valuable celestial resources. The space race is no longer just about reaching the stars. It's about who controls the future of resource exploitation beyond Earth. The future. What's next? The next few years will be critical for asteroid mining as companies transition from concept to execution. Astroforge's plans for a 2025 asteroid landing mission mark an important step toward demonstrating the feasibility of commercial mining operations. The company aims to show that it can extract and refine valuable materials on site, reducing costs and logistical challenges associated with transporting raw materials back to Earth. NASA's OSIRIS-REx mission, which returned samples from asteroid Bennu in 2023, has already provided groundbreaking insights. These samples revealed the presence of water-bearing minerals and organic molecules, confirming that asteroids can serve as reservoirs of both water and building blocks for life. This data is guiding future missions, including potential collaborations between public and private entities to identify and target high-value asteroids. Additionally, advancements in robotics, AI, and propulsion systems are expected to accelerate, driven by investments from governments and venture capitalists. The European Space Agency's Hera mission, launched in 2024, will further explore the mechanics of asteroid deflection and surface impact, providing critical data for mining operations. With these milestones on the horizon, the asteroid mining industry is poised to transition from science fiction to a transformative reality. Thanks for joining us on Trendsetters. Don't forget to like, subscribe, and hit the bell so you won't miss any groundbreaking insights. Until next time, stay curious and keep exploring.